All right, folks, moving on to section 9.3, which is rotations. And rotation here, about a fixed point, is called a center of rotation through an angle of x is a function that maps a point to its image. So we will usually go with 90, 180, or 270, but there just shows you that you can go 120, you can go different ones, and you have an angle rotation, and everything is, so angle point A right here, you would go 120 from point C, and it's the same distance, but just 120 degrees, and that's going to be counterclockwise. So rotation is a transformation that turns a pre-image a specific degree around a fixed point. Angle of rotation is the angle which the pre-image is rotated. Can be CCW is counterclockwise, CW is clockwise. This example right here, if we're going from D to D prime, that would be a 60-degree counterclockwise turn. This one they show you actually from C. This is point C right here. You would measure this is 60 degrees. Counterclockwise goes this way. Clockwise goes this way. So as we go through. So down here we have a practice. 90 degrees is a quarter rotation, which is the same as going 3/4 in the opposite direction. 180 is a half rotation, whether which way you go. 360 would put you back to the original. So this example right here is going to be a little bit challenging unless you have a protractor to do a measure, which I'm assuming you don't. But if you kind of take a look and see where we're at and just kind of guess with, they say for the diagram which description identifies the rotation of the triangle. So start with point A. So if I go point A through that to here, that's a 90-degree angle. Is it clockwise this way, or are we going counterclockwise? And again, in order to understand that, you have to know what's the pre-image to the image. Well, this is your pre-image, this is your image. So you're going, we're going counterclockwise. Final answer would be D. Next slide, this is exactly what you want for your key concepts. And the most important part here that you're going to realize is when you do a 90-degree rotation, they don't necessarily always tell you if it's clockwise or counterclockwise, so the default is counterclockwise. So if we say 90-degree counterclockwise rotation, this is the symbol you're going to use. You're going to take your ordered pair XY, and you're going to move it to negative YX. And you can see what that looks like here. They took point P, which was 5,2, and they moved it to P prime, 90-degree counterclockwise, negative 2,5. 180-degree rotation, really it's the same whether you go clockwise or counterclockwise. You take XY and you go negative X, negative Y. Point P, we start at 5,2. It ends up at negative 5, negative 2. 270 counterclockwise rotation right here. You're going to take your XY and make it Y, negative X. So if you take 5,2 right here and you go 270 counterclockwise, goes this way, which is the same as 90-degree clockwise, and you would end up with 2, negative 5. That's a phenomenal example. Really enjoy that one. So you're going to have a triangle here to start with, and they want you to rotate 90-degree counterclockwise about the origin. So what you have here is you're taking your XY, and you're going to move it to negative YX. So your A, which is 2, 3, is going to become negative 3, 2. And I need parentheses around that. My B prime, which is 6, 3, is going to become negative 3, 6. Our C prime, which C is 5, 5, the C prime is going to be negative 5, 5. Okay? And then obviously I'm assuming that you're able to graph those at this point. Next slide here. Next slide, they want you to take the hexagon, and what is the image of point T after a 90-degree counterclockwise rotation of the origin? So the first thing you'd have to do is find where T is located. So we would count 1, 2, 3, 4, 5. So we know that X is 5. We'd go up 1, 2, 3. So we know that T is located at 5, 3. And then they want you to do a 90-degree counterclockwise. 90-degree counterclockwise, we're going to go with negative Y, comma here, and negative YX. So you take your original ordered pair, You flip-flop them, take the opposite of what y is, so that your final answer should be C, -3, 5. This just shows you exactly what I went through. You can read through if I went too fast. Now you're doing the same type of an idea. What is the image of point Q after a 90-degree counterclockwise rotation? You're doing the exact same thing. Hopefully you try it on your own and you end up with point B. This one right here, you're going to have another triangle. This time we want a 180-degree rotation. So you're starting with those same ordered pairs. I'm just going to give you the answers. We should have a new A prime, which is going to be -2, -3. Our B prime is going to be -6, -3. And C prime is going to be -5 and -5. So again, if you're flowing with what we did there, or we should have already had it, you're taking your original x. I should have put this up first. I apologize. So you take your original x, y, and you're making them -x, -y. That was our rule, which we should have gotten from the other sheet to receive those answers. And then again, if they want you to graph, you should graph. Next one here is going to be a 270 counterclockwise rotation. You're taking your x, y, and you are making this a y -x. So again, take all of your original ordered pairs. I'm just going to give you the answers again. A prime is going to be 3, -2. B prime is going to be 3, -6. And C prime is going to be 5, -5. So again, if you're not understanding, as I'm thinking here, if you don't understand what that means, my original ordered pair of A was 2, 3. So this is my y. So I now move it to the front. So this is the y, and this was my x. I now take the opposite of it and move it to the back to match here. So that's how we walk through to get those. And then obviously I'm looking for you to graph. And then the last one here, I'm not sure if you can do this or not, but they want a 70-degree counterclockwise rotation. 70-degree counterclockwise. I'm just going to give you the answer on that. And again, how you would do that is you would go with here. You would go from here to the origin, and then you would kind of measure that to see if that goes there to match. Great job, folks.